section 2.6. We skipped section 2.5. Did you guys know that? Okay, we're skipping 2.5, so we're going straight to 2.6, identify transformations. You have 3 sheets of paper for this section. One that is like a peach color, okay? One that is your note sheet, which we're going to fill in tomorrow. So we're not going to do anything with this except use the bottom part down here. And then you have your homework sheet, okay? So there's 3 sheets of paper that goes with this. The bottom part here is what we're going to use first. So what I want you to do is, this is your little quiz that we have going on here. We're going to write in some functions and figure out what they look like. So the first one is y equals x. Put that graph on your paper. And you fill in what you think y equals x looks like. You should know this. Okay, some of these you will not know. But you should know what y equals x looks like. Okay, the next one. Y equals x squared. Fill in what you think he looks like. The next one. Y equals x to the 3rd power. Fill in what you think he looks like. Okay, you can take a guess. That's fine. I don't care. Here in just a second, we'll fill in what they actually look like, but please take a stab at what you think he looks like. Okay? And don't cheat. These are all on your orange sheet, but don't cheat. Okay? All right, the next one. Y equals x to the 4th power. See what he looks like. And then we'll do x to the 5th power. Those 5. We'll add one more here in just a second, or a couple more. 4 more, 5 more. There you go. Okay. Take a stab at what you think x to the 5th power looks like. X to the 5th power. Okay. Next one. Y equals the square root of x. Take a stab at what you think he looks like. And then we'll do y equals the cubic root of x, which is written like that. Just have a little 3 in there. Okay, take a stab at what you think those look like. Okay. 2 more. We'll do 2 more. We'll do 9 of them. Next one, y equals 1 over x. We've talked about him before. Yeah, it is. Well, yeah. No, it's not a linear function. You're right. 1 over x, not a linear function. Okay? And the last one, let's do y equals c, where c is a constant like y equals 3 or y equals -5. Graph what he maybe looks like. Y equals a constant, where y equals a number. Okay? Write what those guys look like. Okay? If you're watching this video and you want to skip ahead, that's fine. I'm not going to run it through the normal software, so you can skip ahead if you want to. Did they give you enough time? Okay, so y equals x. You should know what that looks like. What does it look like? A straight line. Straight line through 0, 0, just like that. That's what he looks like. Okay, what about x squared?
Is it a parabola?
It is a parabola. Like that. Y equals x squared. Okay? Do you remember what x to the 3rd power looks like?
It's like that gun.
Kind of like a sideways S, maybe?
Oh,
Ish. Like this. That's what x to the 3rd power looks like. Okay? Now, x to the 4th power kind of looks like x squared. You remember me talking about that? X squared. It looks like a parabola, but it has an extra hump in it. So it kind of looks like a W. Ish. Okay? Now, what does x to the 5th power look like? Kind of like x to the 3rd power, but with an extra hump, right? Like this. That's x to the 5th power. Something of that nature. It doesn't have to look exactly like mine, but just make sure it's got a couple humps in it. That's what x to the 5th power looks like. Okay? All right? Am I going too fast? No? What about the square root of x? What? Not. What do you mean by straight line? Taking a stab.
It's a ray.
Kind of, yes, it is.
It's curved ray.
It's like this, okay? It's a dot here and it goes that way. Okay? Dot there and it goes that way. Now, X, the square root of X is a special one because he stops right here. He does not go beyond and down into the negatives. Why not?
You can't have negative square root.
You cannot have a negative inside of a square root. If you think about what like the square root of -4 means, it means what can I multiply by itself to get -4? Well, if you take a negative number times itself, it will turn positive. If you take a positive number times itself, it will stay positive. So there's no way I can have a negative number inside of a square root. Okay? That can't work. What about the cubic root? What does he look like? Cubic root.
Same thing with
Yeah.
It's the L.
Oh, no, cubic root. Never mind.
Cubic root is going to look a little bit flatter than the square root, but it's going to go in the negatives. Because if you think of like the cubic root, I can have a number that I can multiply 3 times to get a negative number, like the cubic root of -8. You know what that is?
No.
What times itself 3 times will give you -8?
-2.
-2, right? So I can have negatives inside of a cubic root, but not a square root, right? What does 1/x look like? That's the boomerang thing, right here, like this. Those are the L's, okay? And the last one, y equals c, we've done those before. Like y equals 3, what does he look like?
Straight
it's a
line.
straight line through.
A straight line is a horizontal line. So y equals 3 looks like this. Or -5 would be like a line down here, okay? Okay? So those are those functions. Now, my calc class just got done filling in this orange sheet or peach color or whatever. We just got done doing this on Friday. We filled this grid in just like you're going to do today. They are doing it as review. You guys are learning this for the first time. So what you're doing with this, all of these rules carry over for trig and calc. And the sooner you learn them now, the easier life will be, all right? The reason why we're learning these transformations, and a transformation means like moving stuff around, is like, for example, if you do, let's say I have y equals x plus 2 squared minus 3, okay? If I strip away all of the numbers, the 2 and the -3, what type of function do I have? If I strip away all of the numbers, what do I have? Y equals x squared. I have y equals x squared. So, this guy, to graph him, graphing this equation, the only option I have right now to graph him is to plot points, like -2, -1, 0, 1, 2. I don't want to do that, okay? But if I know that his parent function, or he looks like y equals x squared, I know that this 2 moves him to the left 2, and this 3 moves him down 3. Okay, that's what those numbers do to that function. So my parabola of x squared looks like this, and I just shift him to the left 2 and down 3, and now I have him graphed and he's done. Rather than having to plot points and life being more difficult, I have it graphed right now, ready to go. Okay? It makes life so much easier if I know those rules, and those rules are the same for a quadratic function, for a cubic function, for a linear function, all of those different types of functions. It's the same way, okay? So, the reason why we learn these rules is to make life easier, okay? And it will make your life a whole lot easier, all right? Go back to this guy. On the front side of this sheet is all the parent functions. We just got done doing those, so this is your constant function, the horizontal line, a linear function. This is, oh shoot, we didn't do absolute value. Crap. Absolute value is a v, okay? You will not use this function in algebra class. We will use that in calc and in trig, but you will not use this function. This is a greatest integer function, or a step function is what it's called. We won't use that in algebra class, right?
The first question on homework, absolute value.
Absolute value? We will use absolute value. Yeah, we will use this one. Absolute value is this one, okay? Greatest integer is this one. We won't use greatest integer, but we'll use absolute value. Now, absolute value, let me talk about him for just a second. He is y equals absolute value of x. Now, y equals absolute value of x. If I strip away the absolute values, I just have the equation y equals x, right? Which looks like this. But what does the absolute value mean? It's only positive, right? Which means this guy right here gets moved, and he looks like a v now. Does that make sense? That's what the absolute value of x looks like, okay? So there's that. All right? So these are all the parent functions. We won't do the greatest integer function. We'll just do like the rest of those. But those, and we did some that are not on here, like the fourth, or x to the fourth power and so on and so forth, okay? So there is that. Now, going to this grid, we are going to fill in these first two columns right here. So skip these 4 columns. We're going to fill in these 2. And then we'll go back and fill in those 4 columns here in just a second, okay? All right? Now, here are the rules. Here are the rules. This is y equals x. This is a linear function, so it looks like this. Whoa. Looks like that, going through 0, 0. Okay? This is also a linear function. How do you graph him? Start at 3, go up 2 over 1, or down 2 to the left 1, and he's going to look like this, right? That's what he will look like, okay? That's that function, all right? Now, here are the rules. Let's say I'm taking those functions and I am translating this graph up 6 units. So he's going to look like up 6 units. He's going to look like this instead, okay? Instead of this, he's going to be up 6 units. What does the equation change to be? How does it change the equation? Plus 6, y equals x plus 6. You can kind of see from there that that means you start at 6 and you go up 1 over 1, up 1 over 1, okay? Now, what happens when you're going down 5 units? Yep, y equals x minus 5. Down 5 units means minus 5, okay? Now, we're going to do the other column at the same time because when it's just y equals x, it makes it a whole lot easier. But when it's x, when you're starting with 2x plus 3, it makes it a little bit harder, all right? So the plus 6, where is that going to go on my 2x plus 3? You're going to add it to the end. So 2x plus 3 becomes, or plus 6, it becomes 2x plus 9. That's my new function. Yeah, I think I have 9 hours study hall, but we go to the library. Yeah, over. Okay, so 2x plus 9 is what he becomes, all right? What about the minus 5? Plus 3 minus 5, so that will be 2x minus 2. That's what my new function is. Okay, I'm getting lazy. I'm not writing y equals and y equals, but whatever. Okay, so 2x minus 2. So visually, you can kind of see how that works as a linear function. When we started at 3 above, going down 5, now I'm starting at negative 2 and going up 2 over 1. I didn't change the slope. I'm just shifting it up and down. All right. Now, put a little star by this one, by both of these. Okay. Horizontal translation, because this is where it gets weird. Okay. When you're doing a horizontal translation 9 units to the right, you got any thoughts about how you do that one? 9 to the right. No, no. This is what he looks like. He looks like y equals x minus 9, like kind of in parentheses. Kind of in parentheses. X minus 9 in parentheses. Okay? Okay? Now, when you have a, just wait, he's in parentheses, but the reason why I say kind of is for a linear function, you don't need to write this down, but for a linear function, when you're starting with y equals x, okay? Let's talk about minus 9 being 9 units to the right, okay? Y equals x minus 9 when it's in parentheses, since you have no number outside of here, is kind of like x minus 9 like this, without parentheses, okay? The parentheses really, when it's just y equals x, do nothing, right? They really don't do anything. So basically, this guy where it's right 9 is the same thing as what's this doing? No, not up 9. Down 9, right? To the right 9 and down 9 mean the same thing. Let me show you what that looks like. Going 9 units to the right, when I have this function right here, 9 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, now looks like this. Wait, that's also down 9. You see that?
No.
Taking that function and shifting it to the right 9 units is the same thing as shifting it down 9 units. Now, that only works when you're starting with y equals x, okay? Because when we do it up here for 2x plus 3, this x minus 9 goes in here, okay? Instead of being 2x plus 3, the x is being replaced with the x minus 9. That's why I put it in parentheses, is because he's being shoved inside where the x is. Does that make sense? Okay? So when we do that, when we distribute the 2, 2x minus 18 plus 3, or 2x minus 15. That's what he will look like. Okay? That's what he will look like. I'm kind of running out of room. Sorry.
Where do you get the 15?
Because 18, negative 18 plus 3. I saw that plus 3 on the end there. So minus 15. Yeah? Good? Okay? Now, what will 4 units to the left look like? It's x plus 4, okay? When you're doing horizontal translations, the reason why I had you put a star over here is because you use the opposite sign, okay? When you were going up, you use positive. When you were going down, you use negative. But when you're inside parentheses, minus actually means right, and negative actually means, or minus means right, plus means left. Does that make sense? You use the opposite sign for a horizontal translation. Minus means right, plus means left, okay? So inside here, this would be 2 parentheses x plus 4 plus 3. Instead of it being 2x plus 3, you replace that with x plus 4, and then you distribute the 2. So he will be 2x plus 8 plus 3, or 2x plus 11. Okay? And again, for a linear function, going 4 to the left is kind of like going 4 units up. 4 to the left and 4 up is the same thing, only for a linear function. When you do 2x plus 3, it won't be the same. Okay? Whew, these are the rules. These are the rules. I give it to you on a cheat sheet like this. Okay? All right. We spend 2 days on this because this is like being introduced to you for the first time, and it's kind of confusing, all right? Next one, vertical stretch and compression. So, vertical stretch, if you think about what that looks like. Where are my tall people in here?
Mackenzie.
Brooklyn's kind of tall. McLean's kind of tall. You guys are vertically stretched, right? Okay, I am vertically compressed. Sorry, I am vertically compressed. Yes, I am. I'm vertically challenged. Vertically compressed. Okay. I know. I'm vertically compressed. Right. Exactly. That's what happened. Okay. So, a vertical stretch. Okay. Like Brooklyn or McLean, they're tall. A vertical stretch. Listen. If I take the function y equals x again, where this one is up 1 over 1, up 1 over 1, and I vertically stretch it, it's going to look kind of more like this, right? Vertically stretching it stretches him up. Colton, turn around. Okay, I vertically stretch him. He's going to look tall and skinny, okay? So instead of going up 1 over 1, up 1 over 1, up 1 over 1 like that, this guy is going to go up 5 over 1, up 5 over 1. So how does that change my equation? My slope becomes 5, so what's that look like? Y equals 5x. Now we're multiplying, right? Okay? Now what does it look like when I'm vertically compressing something? This is by a factor of 1/3. So y equals 1/3 x, right? Because 1/3 is going up 1 over 3. I'm making it shorter and fatter, okay? So now if I start with the function 2x plus 3, it will be 5 times 2x plus 3. I'm multiplying the whole thing by 5, which really actually becomes 10x plus 15. Does that make sense when I distribute the 5? Okay, that's my equation. All right, the 1/3 x, if I take 1/3 times 2x plus 3, what's 1/3 times 2x plus 3? What will that look like? 2/3 x plus, what's 1/3 of 3? 1. 2/3 x plus 1 is what he will become. That's a vertical compression. Okay? Huh. Look at that. Okay, now, horizontal stretch. Last year, when I did this lesson, or when I taught this to my algebra kids, I was pregnant. So I was literally a vertical compression and a horizontal stretch. I still am, because it's after lunch, so I have a food baby now. So I am horizontally stretched right now, okay? Some of you guys are like really super horizontally compressed because you're like tall and skinny, Okay? Sorry, I am not the same way. Okay? So anyway, so a horizontal stretch looks like this. Put another star by this guy over here, because crazy things happen when you're doing horizontal stretch and compression. You use the reciprocal. Use the reciprocal. I did not spell that right. You use the reciprocal, which means you take your factor and you flip it. All right? So a horizontal stretch by a factor of 2, here's what this guy looks like. In parentheses, he will be 1/2 x. In parentheses, he'll be 1/2 x. Okay? Because I took the 2 and I flipped it. 1/2 x. Just like that. Okay?
Oh boy.
1/2 x. Okay? Now, when you are doing linear functions, that parenthesis really doesn't mean anything. Okay? So supposing I had the same factor, like a vertical compression by a factor of 1/3 and a horizontal stretch by a factor of 3, those would look exactly the same. Okay? Because if you take a peanut butter and jelly sandwich and you vertically compress it, what's going to happen?
It's flat.
It's going to horizontally expand, right? So sometimes doing that will end up with the same thing. All right? Now, here's where it gets tough. When you plug this into the equation, you're putting the 1/2 x inside where the x was. You're not multiplying by 1/2 through the entire thing. You're just plugging it in place of that. Okay? So it'll just be x plus 3. That's what he will look like. Okay? What does the next one look like? Okay? Instead of 1/4, the horizontal compression will be y equals 4x. So 2 times 4x plus 3. Or 8x plus 3. Does that make sense? Yeah? Okay? So funny things happen. And if you look at this, horizontal, 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 horizontal. When you're doing a horizontal stretch or compression or a horizontal translation, you're going to do funny things like flipping the sign or using the reciprocal.
Wait, but the horizontal stretch.
Horizontal stretch, yes. We put 1/2. Yep.
Yeah,
Okay. Now, the last two. A reflection across the x-axis is y equals negative x. Reflection across the x-axis, y equals negative x. So, negative parentheses, 2x plus 3 is what he looks like when you have a big function, right? But then we distribute that negative through and it looks like negative 2x minus 3. Okay? Now, the last one, this is what he looks like. Y equals parentheses negative x. Okay? So what is the difference between these two right here? Other than one's in parentheses and one's not, right? Those two actually mean the same thing if you look at what that looks like. Y equals x is this graph right here. If I flip him across the x-axis, he'll look like this guy.